Hello, everybody, and thank you for joining us for class openers and quick games to foster numeric, algebraic, and geometric thinking with David and Oscar. We're so excited to have you all here. I'm going to give everybody just a few minutes to get logged on and ready for the webinar. So within the meantime, please go ahead and just share in the chat. Where are you from? What's your name? What's your role at your school district? We'd love to hear from you. Ohio, very cool. I'm over in Indiana, so we're like state neighbors. Very fun. Is there anyone from Indiana here? Because I never see Indiana in the chat. We're Ohio, Springfield, Austin. Very cool. Georgia. I'm in Indianapolis, Laura. So my grandfather's from Evansville, though, so that's pretty cool. West Virginia, New Jersey. Fishers, Indiana. Yay. Hi, Greg. Nice to have you, our special guest. No, I'm just kidding, but you're all our special guests. Michigan. Lots of people around where I'm at today. Always very fun. Okay, so I'm going to go ahead and get us started. So again, thank you for joining us for class openers and quick games to foster numeric, algebraic, and geometric thinking with David Porras and Oscar Perales. We have two incredible speakers today, so I'm very excited. To get us all started, I'm just going to go ahead and share a couple of quick helpful tips to participate in the webinar. If you would like to access closed captionings, you can do that at any point in time during the webinar by clicking the CC button in the bottom tray of your Zoom, and that will pop up and bring up subtitles for you. Feel free to participate in the chat at any point in time. We love to see that you guys are engaged and excited. But if you do have questions, feel free to please drop those in the Q&A feature of Zoom, because we will be using the Q&A function. And that way, David and Oscar can answer your questions at the end of our webinar. You will receive a certificate of attendance and a recording of this webinar at the end. You should receive that email within a day or two. We try to get it out as soon as possible, but sometimes it takes a little bit of time. And with that, I would like to introduce you all to David and Oscar. David is our Senior Director of Product for Polypad and a studio at Amplify, and he has 20 years of classroom experience. And then Oscar is our math specialist on the teaching and learning team here at Amplify, and he has just a great passion for technology in the classroom to help empower teaching. So these are two of the best speakers I could possibly think of for this webinar. They're both incredible, and I'm very excited for everything they have to share with you. So David and Oscar, go ahead and take it away.
Thanks, Ryan, for that great intro. Welcome, everyone. I'm Dave, really excited to be here. And I'll pull up my screen while Oscar says a quick hello as well.
Yeah, thanks, Dave. And Dave, I think we need to have Ryan always just introduce us, because it makes us sound so amazing. So yeah, happy to be here I said Dallas, Texas in the chat, but then I realized I just moved to Houston. So technically it's Houston, but it's, anyways.
Awesome. Yeah, thanks, Ryan, for that great intro. We are really excited to do some class openers and quick games with you on this webinar today. Awesome. It was fun being in Wisconsin last year. Thanks, Alice. Yeah. Really hard to do some of these over a webinar rather than in person and in the classroom. We're going to do our best to have some fun doing some math with you. Loved seeing all the intros in the chat, and we're hoping you can keep those good vibes rolling in the chat and participate along with us via the chat today. Many of these are designed as like, you have 5 minutes at the end of class and your lesson is over and you want to pull up a quick math activity. You're in between blocks at the elementary level. You're about to transition to lunch maybe, and you have 5 minutes. and you want to do a little bit of math, just like little bite-sized math moments that can add some joy, some creativity, some fun to your math classrooms. And most of these are designed where the teacher is projecting on the screen, the teacher's on a device, and the students are not even on a device. The students are talking to each other in small groups at their desks, doing some work on a whiteboard, maybe standing up at their whiteboard. So in some regards, this like webinar format kind of works in that I'm projecting right now and you're on a device, but you're not going to be doing the math that Oscar and I are doing the whole time. So with that, let's jump in. And I'm going to do a quick little warm up here with a function machine that we have on Polypad. So I'll get into some of the details of Polypad in a few minutes. Here you can see this is a function machine with an x+1 on it. I'm going to give you a Polypad tour in about a minute here, but let me just show you that I can go over here to the number section, and I'm going to add a number card, and I'm going to drag it out and put it into the function machine. And because it's an x+1 machine, out comes 4. Right? If I put in 10, out comes 11. I could put in a number bar. It'll come out as a number bar. Hopefully you can hear the nice sound effect. But I've made this machine here where I've turned off the rule. You can't see the rule here. And so I wonder if we can play a little guess my rule Zoom webinar style. So I'm going to drag in a few tiles. Don't put your guess in the chat just yet. Try to hold back. But think about maybe jot it down on a piece of paper. Having a little piece of paper in this webinar might be really helpful as we do some of these activities. So, all right, let me drag in a number, but then I would like to hear some numbers from you all that you'd like me to drag into the machine. So I'm going to drag in a 7, and out comes a -17. Alice wants me to put in 9999999. Awesome. I will drag in a 1, and out comes a 1. Whoa, I didn't even mean to do that. All right, let me do 99999. Love it, Alice. That's what a student would say, right? So I'm not going to do that on a number card. I'm going to do this down here with my equation tool. And I'm going to type 9999999. I think that was how many nines you had. And I can drag that in. And out comes some scientific notation. So maybe a good time to dive into that with students if you want to do scientific notation. And I think I saw a -3/4. So let me do that on the number cards, -3/4. There we go. I can get a fraction on this number card, and it comes out as 6.25. But if I wanted to, I could change this number type to a mixed number, just to see it that way. Now, I have lost track of all my inputs and my outputs. And so to do that, to show that, I'm going to click on the function machine, and you can see this action bar appears here. And this action bar is where a lot of the power of Polypad comes in. So let me zoom out a little bit. And I'm going to click tabulate, and I get this table of all the values that I've put in into the machine as well as their outputs. So I can keep track of that. I don't have a guess yet of the rule or another input output that they want me to put in here as we make our way to finding this rule. I could put in 3. Oops, I missed. Where'd my 3 go? There it is. And out comes -5, and you can see that gets added to the table as well. Every new point I put into the table. Of course, we have some math teachers here in the mix. They want me to put in 0. I will do that for us and put in 0, and out comes 4. Obviously, depending on the age of students, you could make the rule appropriate for their mathematical understanding. Maybe at this point in class, I would pause, let the students talk in groups, see if they have a guess of the rule. What I also love here, I can, on this table, there's an option to make a scatter plot of the points that I have so far. And you can see, because Alice gave us such a huge number, it's counting by the 20 millions, which is wonderful. But it's not very helpful to see the pattern of numbers here. So I'm gonna click on this, and I'm gonna change the X scale. Oh, what happened? I went to the next screen by mistake. Sorry, I hit the wrong button. I'm going to change the scale of this from 20 million to maybe 10. And then I'll change the Y scale from whatever that is to, let's make it a little bit bigger. Let's go up to 50 maybe. There we go. Oh, that's probably too much. Let's go 10. All right, so now I can see those points, not including Alice's Great points. No worries, Alice. I love that you did that. That's what students are going to do, right? They're going to be like, do 9999999, and you can value their thinking and do it and talk about scientific notation and scales of graphs, which is kind of fun in the moment, or you could skip it. I like to value that. Does anyone have an incorrect rule here that they know the rule is the wrong rule? I'd like one incorrect guess. If we could. Y equals X. Awesome. Thank you, Al. So I'm going to go to my equation tool and I'm going to type in Y equals X. Make this a little bit bigger. And I see on this equation, I have this like blue triangle, which is the starting of a connector wire on Polypad. And so I can attach that to my graph and I can see that that hit one of the points. It hit the 1 point, but not all the rest of my points. So that's a great guess. Great job finding a rule, Alice, that went through one of my points, but maybe I want the line going the other way. So there's negative X, and we could adjust accordingly. In the interest of time, I'm going to jump to the rule here, and I'm going to go onto the function machine, and I'm going to turn on this toggle to show the expression. So I'm going to turn this on, and there's the rule, negative 3x plus 4. So I can change my rule to that, and I see that it matches up. And again, that was a very middle schooly rule. You could have made a one-step rule with just multiplication or something, whatever rule fit for your students. Okay, so that was a brief intro to one quick activity. I'd love to invite you to join this activity. So I'm going to put this link into the chat here. Oscar is so on top of it. He was ready to go. There's the link. Thank you, Oscar. There was just a question, are we sharing these electronically? Here you go. Now, this is a Desmos classroom activity where Oscar and I can pace and pause you through different screens. So I'm going to allow you to go to screen 3 here. I didn't want you to go to screen 2 at the beginning because you could have clicked on the function machine and you could have seen the rule. I didn't want you to do that. I wanted to build that up a little bit. And if you go all the way to screen 3 here, screen 3 is a Polypad. This is a blank Polypad canvas. Polypad is an open canvas, part of Desmos Classroom, totally free and open for everyone around the world to use virtual manipulatives to explore, create, discover mathematics. And I'm going to go into full screen here and give you a few minutes just to kind of play on Polypad. Everything Oscar and I are going to show you today was built on Polypad inside of Activity Builder. No engineering needed, no fancy graphing calculator knowledge needed, just dragging of the manipulatives onto the canvas here. So you can see under geometry, there's a polygon section. You can drag out a variety of tiles. You can rotate them. They snap in place kind of nicely. So I could make a variety of things with these polygons. I'm going to select 3 of them and rotate it around this way. And they snap in place. When I select a group of these polygons, I can click Fold Net, and I get this like hexagonal prism without a top on it. We could spend a whole hour just on polygons, and I would never let Oscar talk, which is not fair. So you can go explore. There's a number section. We have base 10 blocks. There's the 100 cube, or the 100 block. I can click Split, and it splits into the 10s, and I can take the 10 and split it into the 1s. I can go to the fraction section and find fraction bars. I'm using Polypad inside of Activity Builder right now. You can also use Polypad outside of Activity Builder at polypad.amplify.com. That has some getting started pages. We'll put that into the chat in a few minutes. But the value of using Polypad inside of Activity Builder, I'm on my teacher dashboard now, and I can go to the teacher page. Let me turn on anonymize, and I can see what all of you are doing just by playing and exploring Polypad. Some of you found our Rec and Rec, which is there. I forgot the name for a moment. Some of you are playing with the spinners, the coordinate plane, all sorts of fun exploration going on. And Lisa, to your question, I added Polypad as an author into this activity, and we'll provide some links to resources at the end where you can learn how to add Polypad onto the screen as well. The great value of doing it inside of Activity Builder right now is I'm able to see all of your work, right? And I love that you're just exploring and playing. That is the goal of screen 3. But in about 30 seconds, I'm going to move us to the next warm-up so then I can turn it over to Oscar, right? But you're getting a feel of all that Polypad can do with the balance scale. Someone's balancing the scale really nicely. I love these dot arrangements as the ways to show factors of numbers. You should be able to join from a mobile device, Vincent. You're probably going to get a message saying that it's a warning of a small screen. It's not going to function great on a small screen, but you should be able to join. Just sort of hit that you accept that it's not going to be great on a small screen. I'll answer one last question, and then I'm going to continue with the activity. You can stretch the pre-made shapes. So under the polygons and shapes, if you click on the More Tools menu, there's an option to apply a scale factor here. So I can apply a scale factor. I can enter in a 3 here, all sorts of fun things. And Rebecca, thank you for the segue to my next activity. So you played a little bit. Let me go to this next activity. I'm going to pause you. It's going to be really like jarring to you right now, but I'd love your attention for this next activity. All right. So in 5 seconds, I'm going to hit pause and you're not going to be able to play anymore. I apologize. All right. You're paused. So now screen 5, I'm going to go to screen 5. And this is a warm up that I would do in class. Again, I like to imagine this with students at whiteboards in small groups at their whiteboards talking to each other. And then like doing the activity there. They also could do it in groups at their desk. But here's the activity. I'm going to play this square, and you're going to hear it in 3 different ways. Oscar, give me a thumbs up if you can hear the audio when I push play. Awesome. If we had more time, I might ask you to put in the chat what each different square is telling you or ask students to talk about it. But I'm just going to hit play one more time. And if you want to play along, grab a piece of paper somewhere, because here I've hidden a shape in this square, and I'm going to play it. You won't be able to hear it. It's not the square that I'm playing. It's some hidden shape. I want you to try to draw the shape that you hear based on these 3 options that I'm going to play. So first, I'm going to play the perimeter. Ready? One more time. And imagine in a class now, students are probably counting on their fingers. They're talking to people next to them. What did you hear? If they're at whiteboards, they're trying to draw it. They're looking at their groups next to them. A lot of good like buzz in the classroom right now. And then I might play the area. And that same round of like, what does that sound like? What does that tell you? I'm going to jump to the end here. And then we could play the angles. And I love that there's that one really long angle. We could have a whole 5-minute conversation about what that one long angle is. But in the interest of time, I'm going to jump right to the next slide, and I'm going to do the reveal to show you what this shape is. But again, imagine students drawing all their shapes and changing them based on what they hear, and you as a teacher facilitating good conversations about vocab. Here is the shape. And I'm sure a lot of you got it because I gave you so much time to think through it carefully. I didn't at all. You had no time to really dive into this, but I can play all of them now. And then here's the angles, which is a fun one to play. Oh. That one really long angle there, and here's the area. Filling it up, right? So good opportunity for like dialogue and conversation. I'm going to skip screen 7. I'll allow you to go play with screen 7 if you want, because I got to turn it over to Oscar. I said I would at 15 past the hour, and I did at 20 past the hour. So a little taste of what you can do in geometry on Polypad. Oscar's going to now do some examples with numbers and operations with some class openers and warm-ups you could do there. Take it away, Oscar.
Awesome, thank you, Dave. Yeah, no, I totally get it, right? It's easy to get lost in all the different manipulatives and all just the different features and whatnot. And so, yeah, so I'm going to be that teacher as well, and I'm going to go ahead and pause you as we move forward here into the next section here, where we're going to be focusing on using these merchant manipulatives from more of a number sense and operations kind of vantage point. So let me go ahead and share my screen. Give me 1 second here. Okay. All right. All right, very good. All right, so I'm going to go ahead and pause this. So 3, 2, 1, pause. And never fear, you'll have access to this activity at the end if you want to explore anything in particular. I'm going to go ahead, I'm going to pause this, and I'm going to go ahead and bring us all to this screen here, see to me. So I should move everyone here to my screen. So as I mentioned, right, so this year we're really focusing on just number sense and operations. The first one that we have is a little bit of a combination of a couple of different components here, right? Again, we've got the number bars there, we've got a balance scale, and then we've got the dice there. We even have an action button. And so as Dave pointed out, right, these are great as a teacher projection, right? So I can imagine having the entire classroom either up on their boards or working in groups, whatever it may be, right? But here I'm going to have my students work in a small group and discuss how can we balance the scale using these number bars here. So as we can see here, it's currently not balanced, right? But then again, we can change this up. Right, again, I get that delightful sound. I can change it back up one more time. And then from here, right, can we come up with a sum, right, using those bars that's going to give us an equal amount. And so, right off the bat, right, I can even start from a very low point, low floor entry, and I can see a 2 there. I see a 6. I see a 3, right? Or perhaps we can even make it more challenging and challenge students to try to use different combinations that don't actually are not represented by those dice there, right? So I see 3 of the singles, it's the same as 3, right? And again, I get that visualization, right? Now you can see that it has been balanced, but again, just really trying to invite that conversation and just trying to compare and connect multiple ways to get that same sum there using that roll. And again, even if I was to roll it, right? Kind of changes it up, right? So it can be something quick, something fast, something for a transition there. Moving along, okay, in a similar kind of situation, but now we've got this here. In fact, I'm going to let you play around with this one a bit. So I'm going to go ahead, I'm going to unpause you. Okay, but again, the same idea, right? Now we've got, we're kind of leveling it up, and now we're trying to write actual equations based on these dice that we have here, right? So we're going to roll the dice, find the numbers and math symbols that are going to make each of those equations true. And so again, open it up for different dialogue and invite the students to share a solution, one equation at a time, just a chance to really, for us to start comparing and connecting, right? And so how this works, again, if I'm wanted to model this here, I can perhaps take this this dice here as a 6. How can I get it to equal 0? Where have I 6? Take away another 6, and so on and so forth. But again, that's my interpretation, right? Dave could have a different interpretation. You could have a different interpretation. And again, I can go into my teacher tab and start seeing all the different combinations that come about here. Ooh, nice. I like what some of us are doing here right off the bat. Yeah, and I can go in there and start highlighting, again, really using that teacher platform to really honor that student thinking and student voice and start making those connections there along the way. So very good, very good. Love it, love it, love it. All right, so I did that. I let you kind of play, and now I'm going to pause here. So I'm going to pause you here in 3, 2, 1, pause. And let's see here. Did not pause. Oh, why isn't that letting me pause? There we go. All right, a little bit of a here we go. All right. And so on these next here, what I really love about these, it has an element of a time to it. You know, and a lot of times when we think about, you know, there's a lot of research that says out there that, you know, just to be, you know, fast at math doesn't really necessarily equate to fluency in math. But what I really love about this is it really kind of builds an opportunity, a need for students to be engaged in this short activity, and also really invites dialogue, if you will. So here in this setting, right, we've got my my dice here. I can go ahead and I can show the dice, right? And I could even start off with the class, right, and just talk about here's the dash, so we can see, we can enroll it. What's the sum do you see? We can have a whole classroom discussion. And then once we even talk about different strategies, right, we can then hide it, right? I can hide it. I can roll it again if I want to. And now I can flash it for 2 seconds, right? And invite students to really pay attention, right? Again, same thing. Can you figure out what the sum is?
Ooh, that's a good one. Put it in the chat if you saw it. I didn't get it. That was too
Yeah.
quick for me, but
Yeah. Go ahead. Yeah, drop it in the chat if you saw that. I'll go ahead and flash it one more time.
one more time for me. Oh, that was a good one.
Yeah, that was a good one. But again, right? Imagine you're in the classroom, you're getting students to start talking like, I'm starting to see 25, I'm seeing 20. Well, thank you, Tracy, for dropping their learner to know what she saw there. She saw 16 plus 9. Again, just multiple ways, right? The students are able to now, again, building that need for that numerical fluency, building that need for students to engage in the conversation, right? Perhaps, you know, if I'm looking at this and I'm having a conversation with Dave, you know, I saw those 3 5s. So in my head, I'm already grouping them and seeing 15. But perhaps, you know, Dave saw something different. Again, that's the beauty of this here, right?
What I love is that there's someone who saw 16 plus 9. Like I would have never seen the 16 and the 9. I forget who that was.
Oh, right. Yeah, from the top and the bottom.
Yeah. The top and the bottom. Yeah, that's so cool.
Yeah.
I was so drawn by the 3 5s being 15. I got so excited that I saw 3 5s. I went right to the 15. But that's the point of this. Good dialogue and sharing of strategies, right? Sorry to interrupt.
Exactly. No. Thank you for adding that. And again, I think that's the beauty of this, right? It has a little bit of a time element to it, but as long as it's in a safe learning environment, inviting that discourse, which is what we want our students to be able to do. So yeah, thank you for sharing, dropping the different ways of thinking there along the way. Moving along here, again, the same sort of idea of sort of kind of flashing, right? And we sort of kind of build it out a little bit more and have a conversation of which of these sides is bigger, right? I can flash this side here, you know, introducing the blocks compared to the right side, right? Again, one more time, which is bigger? Is it the left side? Is it the right side? Feel free to drop your response there in the chat. But then even, you know, as we're going through this, right? And if we go ahead and we show them, perhaps students are going to say at first glance, wow, yeah, the left side looks like it's bigger. I see more of the blue. I know the blue is equal to 10. So the left side is bigger. But again, what I really love about this is, again, I can take these unit blocks here, right? I can organize them. I can even merge them. Right. And now we can have a conversation, right? Of, oh, wait a minute now, based off of that new information, right? Which side is going to be bigger? So again, really being in tune to the information that's being laid out there for you. Okay. Same thing from this standpoint, right? Again, same concept of, you know, do you want to flash it? Do you want to show it? Here we're adding a little bit of the algebra ties here along the way. Similar to the other one, they are able to interact with it, right? I can take my my algebra tiles. I can see what my 0 pairs are going to be. Got some 0 pairs there. Got some 0 pairs here. And again, we can have a conversation of which side is going to be bigger. I can even take it a step further, right? And have students take this and how can we write this, right, as an actual algebraic expression? I can use the equation tools here at the bottom, right? And we can write it out, right? I've got positive 2x with a minus 1. Okay, make this a little bigger. I can do the same thing on the other side. Well, I got 2 of the negative x's, so that's going to be a negative 2x with a positive 1. Okay. And then again, still asking the question, well, which side is bigger, right? And not, it can be either or, right? We don't really know. We don't have enough information here. What I love is we can level it up here a little bit more, right? And we can add on these actual tiles here to make this more of an evaluation, right? So I can drop this tile here. I can go ahead and I can name my variable since we're dealing with X, right? I'm going to change that up here to X. I'm going to keep my range here from -5 to 5. That looks good. I always encourage people, you see those 3 vertical dots there, go and click on it so you can see what are some of the tools that we have here. It looks like I have my different increments. I'm going to make my increments of a half. Maybe I want to make that duration a little bit longer, whatever it may be, right? It's just really suited to what you need as your students. But now notice that when I click on these expressions, I have this new button where I can actually evaluate, right? So I can click that, I can turn on the evaluation here, turn on the evaluation there, and now if I play it, right, now it's a, what do you notice, what do you wonder, right? Are they alike, are they different, okay? Which side is gonna be bigger? How do you know, right, based on the X value? Is there ever a time where those values are going to be exactly the same? Like, what is that actually telling us? So, right, even just based off of that, we're slowly starting to build an understanding of what a system of equation is and finding the solution of a system of equations. So, really, really love this screen here. Again, really attuned to using those algebra tiles. All right. And then in the spirit of, again, being able to use the music. Dave, you said it best before. What was the quote regarding music and math?
Oh yeah, our designer engineer on the Polypad team, who's built a lot of these music tiles, has said a few times, which I love. For too long, math has been a silent movie. Now we are adding some sound and sonification to mathematics.
I love it. I love that. Yeah, I love that quote. I think it's so true. From an idea of trying to give students as much multiple representations for them to experience the mathematics. So without further ado, I'm going to go ahead and push play, so you can take a listen to this first track and see if you can figure out what the second track is going to be. All right, so here we go. All right. I'll play one more time. All right, there we go. All right, Patricia dropping it in the chat there. Sees a third, a six. Anyone else? I'll play one more time. I'll play the last one. All right, and the reveal. Here we go. There you go. Have at it. Very good. All right. So yeah, congratulations to everyone in the chat that got it correct. Dave, what do they get?
They get a free lifetime code to Polypad.
Yes, there you go. A lifetime code.
It's free for everyone.
We'll throw in Desmos Classroom.
We'll throw in Desmos Classroom too. You can use it in Desmos Classroom for free. It's always free.
Yeah.
But one thing I just wanted to share, we had a couple of different answers in the chat early on, which is wonderful, right? And so again, in a classroom, you might pause there and say, great, go sound out what you think that is. There are a bunch of people who first thought 1/3, 1/6. And I forget what the rest was in the chat. Like, okay, that's what your group thinks. Stand up and clap that out or something, and then play what's on the screen again. And like, how fun of a moment. And then getting into that conversation of equivalent fractions and what that can mean and sound like, I think can be a really fun, joyful moment of just 5 minutes in a math class.
Yeah, no, totally agree, right? And we think about our students who are just, musically inclined, who perhaps don't see the relation to mathematics. I love the how they two sort of kind of intersect there. So Very good. Thank you. Thank you for dropping the chat. All right, last one that I'm going to look at here, and which I really, really love, uh, is it's got a compilation of a couple different things, right? But the idea here is, right, we've got these set of cards, which I can take, right? I can take these cards here, I can select them, I can turn them over, I can stack them up, right? And I can shuffle them up one more time because I like odd numbers. Okay. And then from there, I can draw two cards, right? I can draw this card. Okay. I'm going to drop it into the balance scale, which we've already seen a little bit earlier. I'm going to draw one more card. Okay. And now what I've set up is, again, if I'm the teacher, I'm presenting this to the class, or I'm working here with Dave, is the challenge is, can you figure out which of those two cards are on the balance scale? And then we even got a couple of dice here to help us use to help us figure that out. So Dave, you want to help me along here? What do you think here?
Can you drag the two dice onto the other side for me?
You got it. All right.
Let's see what that does for me.
Okay, that looks like a helpful move.
That was really helpful because now I know that those are more than 4.
Okay, so it's going to be more than 4.
Yeah, and then if you can drag that. Oh yeah, you covered 4 for me. Cool. No, let's not do that yet. Can you select those two dice on the scale, and can you roll them for me?
You got it.
Thanks, man. Oh, more than 5. All right, that was helpful. Can you drag that little tab over 5? All right. Let's add a third dice on and roll them. Let's see.
Roll all 3?
Yeah, sure. Oh,
all right, you got it.
More than 7, but let's see. Oh, that was really helpful. Because now I know that it is, what's 6? That's 11. All right. So I know the dice add up to 11. And so now I could work my way through and try to figure out the exact 2 numbers. All right, so can you take off, so we could have 3 and 8, we could have 2 and 9. Take one of the cards off and take off the 2 and the 3, please. See if that is 6. Oh, that's lighter than 6. All right, we could keep going, right? We could continue this activity and I could figure out what those 2 cards are. But I think you can kind of see how this activity goes. What is it? 9, 8, and a 3. Awesome. I would do this when I was teaching 7th and 8th grade, not last school year, but the year before. I would do this with if our class was playing a game or something unrelated to this activity, and we had 2 or 3 students that were like the winners at the end. I would pull this out and they would go back and forth trying to see if they could figure out what the 2 cards were, or just again at the end of class for like 5 minutes or something. But even like 6th and 7th graders had a good time trying to roll the dice and balance the scale and thinking about equality and everything. It's great.
Very good. Very good. Awesome. Thank you for that. All right. And Dave, do you want to go jump into probability?
Sure. Yeah. Why don't we jump into probability? And at the end of this session, you're going to get a full page with all the links to this activity, to the teacher version of this activity, to where to learn more about Polypad. So we know we're maybe going a little quick through a few of these games, but we want to make sure just to show a good range of all that's available. And then we will share all the links at the end. All right, so you are synced to me, correct? We're on screen 17. And I'd like to end just with some probability activities, and then we'll open it up to the Q&A and how to learn more about Polypad and all that. All right, so I'm going to go to screen 18. We have a couple examples with dice here. And my question for you, put it in the chat. How many 6s do you think will appear when I roll these 100 dice? So drop that in the chat. How many 6s do you think are going to come up? You can see on the screen the last time I got 14 of them. That was the last version of this. We did this in a conference last summer, right, Oscar? And we had about 200 people in the room. We had them all stand up and tell the person next to them their number of 6s they think were going to come up. And if they got it wrong, they had to sit down. And so even just with 200 people in the room, how many rounds do you have to do that till you find a winner is a fun deep dive into like mathematics. All right, so let's see. If you got it, everybody stand up at home. And if you got it right, you can stay standing. Let's see, roll. 18. I think we had some
18.
18s in the chat,
We
right?
did, we did.
We had some 18s in the chat. We can roll them again. I'm going to roll them one more time. Let's see if anyone gets this the second time. 13 this time. There's 13. We'll do it one more time and see 18 again. 18 came up twice. So could have some fun in class with this activity. Group standing up, seeing how many they can get right in a row. Class of 25 kids, how often to get one person left at the end could be a good time. I'm going to go to screen 19 here. And this is the exact same screen, except I changed the data collection method. And so if I go back to screen 18 for a moment, this table, if you recall on the function machine from the very beginning, I clicked on the function machine and I clicked tabulate and I got that table. You can do the same thing when you select a group of dice. So I made this screen, I clicked and dragged to select all 100 of the dice, and I clicked tabulate, and I got this table on the canvas. And it started in this mode, which it actually starts in a cumulative mode, where it'll do a running tally of the numbers. But I changed it into a replacement mode, where here, each time I roll, the data is replaced with the new results. We got 18 again. Let me see if I get 18 again. All right, 20, there we go. On this screen, though, I've changed it to time series mode. So now every time I click roll, I'm going to get a new row of data into that table. So now my question for you is, how many times do you think I'm going to need to roll these until exactly 17 sixes appear? How many trials of this 100 dice? Katie says 9, Judy says 3, couple sixes, couple fours. Awesome. 10, 3, great. At least 6, love it. Love the engagement in the chat at 40 past the hour. A lot of you have had a long day teaching and you chose to come to this webinar and you're still playing games with us. Thank you for that.
Yes.
It makes the webinar a lot of fun. Oscar, how about you? How many rolls do you think are needed for this?
Oh shoot, that's a good question, Dave. I'm gonna say 3. I'm gonna say 3.
All right, let's see. Here we go. Roll 1. Now that first roll up there doesn't count, right? So it's actually roll 2. I could have made it so the table was empty to begin with, but here we go. Let's see. 20. No. 11. Ooh, that's a good range from 11 to 20. 24. What are the chances of that? Is that an outlier or not? 14, 21, 10. We are getting a wide range here. We have a range of 10 to 24. I still haven't got 17 yet. Come on now.
Yeah,
there we are,
going
17.
On? And the other one, it wasn't this variability. What's going on?
Yeah, I don't know. Interesting data, right? And so here it took 9 rolls. It was the 10th one. But like, even just if we focus on the sixes here, then I could share this with students and say, I wonder if this range of 10 to 24 is expected, or was I getting like unusually low and high? Everyone go it on your own right now. Here's the link. Actually, I could do this. I can unpause you and you could try it on your own. We then could compile, if everyone does this 10 times, we all could compile our numbers into one table, maybe make a box and whisker of it, see if there are any outliers. There's a lot of good data conversation you could have right here, just in this little quick activity. Opens the door up to some good statistical conversations about experimental and theoretical probability. 24, is that like, how far down the bell curve is that, right? Maybe in a high school class, you could explore that and say, what are the chances that you'd get 24? Eric got it in 4 rolls. Nice, Eric. Good job.
Nice.
All right, I'm going to keep this whole activity unpaused and unsynced. So you now have full authority to explore the activity. I will show you one last one on screen 20. Is a similar activity, but now it's pairs of dice. And you can see the table is the sum of those values. So I can roll all of these. And in 10 trials, I can do 1,000 rolls of a pair of dice. I'm not going to do all 10. Maybe I'll do 5. 1, 2, 3, 4, 5. So I just rolled 500 pairs of dice in a matter of 5 seconds, and I got 14 pairs of sixes. And imagine, I did this in my 7th grade classes. I had each student do this 10 times. So they got 1,000 rolls. They reported to me as a, to the whole class, how many 12s they got. Let's say there were 25 students. In 5 minutes, we generated 25,000 trials of rolling 2 dice. And that launched the exploration into the theoretical probability of getting a pair of 6s. And then we could compare our experimental probability and our theoretical probability. And being able to do it 25,000 times in 5 minutes caused those numbers to be pretty close to each other without rolling dice and bouncing them over the floor and only getting 10 trials. We got to 25,000. So that was super fun. All right, in the final closing minutes here, we have some other probability activities that I could share, but let me do a few games and puzzles. And I'll go to screen 23. Screen 23 is a virtual version of a wonderful physical puzzle that you can explore at the link below. And each day is a new puzzle. Do this with 2 dice and get a normal curve as soon as possible. I will do my best, Robert. We could attach a graph to that table and like see how close the bars come up to that. I can show you that in a moment. What's today? February 20-something, 26th? I'm just looking at my phone. That's the date, 26th. So the challenge here is to cover up everything in the grid except February and 26. So I'm going to start with something like this, where I know I have February and 26. And then the challenge is to use all these other pieces to cover everything up. And I did not do a great job here, but I could move the pieces around and try it. And the beautiful thing about this puzzle is every day has a solution. I am terrible at it too, Ryan. I try, but I don't have a lot of successful days. And so, at the end of class, I would often I would just post this in my Google Classroom, and students would do it at the end of an assessment day, maybe just something extra to do. So this is a fun opportunity of just a new puzzle every day.
At the end of class, I think is the key part, because if you do it in the beginning, you might not get. They're going to be too enthralled in that puzzle.
Totally, Oscar, love that. Maybe I'll close just with some links of like how to learn more about Polypad, Oscar, and then we can open up to general like Q&A. Cool.
I think so.
So on this very last screen, there's been a lot of great questions in the chat, which I see in our Q&A as well, around how to learn more. Oscar and I asked Ryan if we could have a 4-hour webinar and spend a half hour on each of these puzzles, and Ryan very politely said no. That's not true. Ryan would have said yes if we'd asked for 4 hours, I think, but it is hard to do all of this in an hour. We're just scratching the surface of what's possible in Polypad. So some ways to learn more. This last screen, the first link goes to the teacher version of this activity. And so when you open the teacher version of this, let's say tomorrow in class, you just wanted to do screen 11, just like roll the dice and flashing them and ask students for the sum. You can click right on the teacher link of this activity, click on screen 11 and do it right there. Ready to go, just that easy. If you want to edit this activity and make a copy of it, you can go to the top, and because this is my activity, I have all of these options. Under your account, it'll just say copy and edit. And when you do that, it's saving this to your Desmos Classroom account. And if you're familiar with Desmos Classroom, you can assign it to students, you can view their work, you get the teacher dashboard. So that's this first link about the teacher version of this activity. And then, as I mentioned at the beginning, all of these activities were using Polypad inside of Activity Builder. But you also can just use Polypad on its own outside of Activity Builder. So this page is an overview page of Polypad. It's got information of how to use it inside of Activity Builder. But if you click on this link just at the top, it'll take you to our Polypad landing page. And then here's a Polypad right here as well. And this is synced with your same Desmos Classroom account. So whatever account you use for Desmos Classroom, you can log in. The same here, save Polypads, get links, share them with students. All of that is really easy to use. And the last, I guess there's two more links that I want to point out. One is on how to author these activities. So you'll notice that this version of Polypad, or even if I go back to our activity, right? Screen 3 is just the blank Polypad. This is like the starting canvas. And when you author something, you're going to be starting from here. But you'll notice a lot of our finished activities, like this one, are really edited down. We've removed the entire sidebar. There's no toolbar at the bottom, but it's all using Polypad. And so there's a page here at the very end that goes into authoring mode. And if you want to build that's our authoring mode video, sorry. There we go. That's the authoring mode video. If you're like, I want to listen to Dave more, you should check your life choices. But you could watch this authoring video where you can learn how to make all of these activities. But on the Getting Started page, there's a link to an authoring, like an authoring tutorial. So if I go to the Getting Started with Polypad page and I scroll down a bit, somewhere in here is a link to the full authoring tutorial page. And the last one, really, this is the last link I'll share, is some of you seem to enjoy the math and music. Gabe Turo, who I mentioned before, is the engineer designer of a lot of the music things in Polypad. And he is currently working on a full collection of math and music lessons and activities by grade level and by subject. So these are public-ish in that we're sharing them with people in webinars and stuff, but they're still going through some final polish and tweaks, but you can explore them. All the way at the bottom here is a link to activities by grade level on math and music. All right, I saw one question in the chat about the nets on screen something. So let me answer that one, and then I'll turn it over to
Oh, we already answered
already
that
answered.
one.
Awesome. All right, great. Thank you. Then I will.
Yeah, no, they were wondering about why one of them wasn't folded, but I was explaining that was intentional, right?
Awesome. Thank you, Oscar.
That was part of it. There are a couple questions on the Q&A though. First one regarding can two students work together on one Polypad virtually? And my answer is no, but I'm going to leave it to the expert.
Yeah, it's a great question. We are working hard on real-time collaboration on Polypad. So it is not ready to go yet, but it's one of the most commonly requested features for multiple students, teacher and student, multiple people from around the world to come to one Polypad link and work collaboratively in that space. It won't initially be live inside of Activity Builder because Activity Builder is a very like session-based use of Polypad, right? Where a student joins with a code and that's their lesson. So it'll initially only work on Polypad outside of Activity Builder, but all within the Desmos classroom.
Awesome, thanks, Dave. And then the other question coming in from Erin, she comments, first of all, I love the ability to remove the unwanted tiles for the students. Less is more. My question is whether or not a reporting feature on student responses is coming in the near future.
Say that one more time, a reporting feature?
Yeah, whether or not a reporting feature on students' responses is coming in the near future.
Yeah, it is coming soon. We do have some abilities to, if you go to the authoring page that I linked in there somewhere off of polypad.amplify.com, there's a link to the authoring page. And in the very last section talks about using a drop zone in Polypad. And if you're familiar with computational layer, you can do some exporting of the student work into computational layer, which then opens the door up to some student reporting of the work in Polypad. So I will get that link and put it in the chat for you. So it's a little bit possible if you know some computational layer, but we do have some other features coming soon for that. Awesome. Oscar, I talked way too much, way more than you. I apologize.
Oh no, it's totally fine. We're in the background over here, making sure that we're answering all these questions. Yeah, somebody asking in the chat. The most important thing is, did anyone solve the puzzle of the day? That's a good one. Yes.
I have not yet today.
I can never get it. like quickly. I love the puzzle of the day, but it always takes me way too long. Well, thank you both so much. I appreciate you guys taking over the Q&A. One last thing for me to do. I did just before we head out, I did want to just share a couple more resources from Amplify. I know that David mentioned that he wanted like a 4-hour webinar on this, and we would have loved to do that. As I said, the two of them were the best speakers I could think of, and they clearly proved me right. But if you want to hear more from folks like David and Oscar, please join us for our virtual free math symposium on March 12th. It is a 5-hour math symposium, and like I said, it is completely free. If you cannot attend the entire thing, or you can't even attend even one session, I would still encourage you to sign up, because all of the sessions will be recorded and they will be available as soon as that session is finished. So you will receive a certificate of attendance and all of those recordings as well. So join us for that free virtual math symposium at amplify.com/2024 math symposium. Oscar is giving a very similar session over this topic as well. So feel free to join us and check that out. If you want to be in the know of all things math at Amplify and you're a K-5 teacher, we really encourage you to join our math interest list at amplify.com/getmoremath. And if you want to join our Facebook community, we heavily encourage you to do so as well. We always have great content being dropped in there, resources, information like the symposium, podcast episodes. So join our Facebook group at facebook.com/groups Math Teacher Lounge. And I did just see one question pop in here about seeing the recordings for these sessions. Again, you will receive an email with the recording and a certificate of attendance within the next couple of days. So keep an eye out for that. Okay, and with that, thank you all so much for joining us. Oscar, David, you both were absolutely incredible. Thank you as always. I can't wait to hear from you guys soon.
Thank you, Ryan.
Thank you.
Thanks, Ryan. Thanks for coming, everyone.